Hello students, welcome to my YouTube channel Dear Mathematics and also welcome to the chapter of matrices. In this particular video session we are going to discuss about the transpose of a matrix. So let us start from the definition of a transpose of a matrix. If A be any matrix, then the matrix obtained by interchanging the rows and columns is called as the transpose of the matrix A. Here is the definition. Let A be any matrix, then the matrix obtained by interchanging its rows and columns is called as the transpose of the matrix A, and it is denoted by A transpose, or you can denote it by A dash. Then if A is a matrix of the order m cross n, then its transpose will be of the order n cross n. That means we have to reverse the order of the original matrix. Then here the ijth element of the original given matrix A will be equal to the jth element of the transpose of A. So let us discuss about some of the examples based upon the transpose of a matrix. So here it is the example. Let A is equal to 2, 3, 5, 1, 7, 9 be the given matrix. Be the given matrix. Then we have to find out the transpose of the matrix A. So before finding out the transpose, let us define the order of the matrix A. The order of the matrix A is given by 2 cross 2. Here A11 is equal to 2, A12 is equal to 3, A13 is equal to 5, then A21 is equal to 1, A22 is equal to 7, A23 is equal to 9. Then we have to find out the transpose of the given matrix A. The transpose of the matrix A is given by A transpose is equal to the first row of the given matrix A will be placed in the first column in the transpose of A. So 2, 3, 5, the first row will be converted to the first column. That means they will be arranged at the first column. Then the elements present in the second row will be arranged in the second column in the transpose of the matrix A. So they will be placed in the second column. So here it is the transpose of the matrix A. Then let us define the order of the transpose of the matrix A. The order of the matrix A transpose is given by it is 3 cross 2. Here A11 is equal to 2, A12 is equal to 1, then A21 is equal to 3, A22 is equal to 7, A31 is equal to 5, and A32 is equal to 9. Then just we have to compare the elements present in the first matrix A and in the new matrix transpose of the A. So let us compare these elements. A11 is equal to A11, but A12 element which is equal to 3 is equal to A21. So A12 is equal to A21 is equal to 3. Then A13 is equal to 5, and here A31 is equal to 5. A13 is equal to A31 is equal to 5. Then A23 is equal to 9, and here A32 is equal to 9. A23 is equal to A32 is equal to 9. So ijth element of A is equal to Ji element of A transpose. So here it is all about the problem based upon transpose of A. Let us take another example so that it will be clear to you. Example number 2. If A is equal to 1, 2, 3, 4, then A transpose is equal to, just we have to interchange the rows and the columns. So it will be 1, 2, the first row will be placed as the first column in the transpose of the A. Then the second row of the matrix A will be placed as the second column. So here it is the A transpose. Then let us consider another matrix of the order of 3. If A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, then A transpose is equal to 1, 2, 3, because it was the first row in the matrix A. Now it will be placed as the first column in the A transpose. Then the second row will be placed as the second column. The third row will be placed as the third column. So here it is the new matrix obtained by interchanging the rows and columns, and this is the A transpose. So here it is all about the definition and fundamental based upon the transpose of the matrix. Then let us go through the properties of transpose of a matrix. Now let us discuss about the properties of transpose of matrices. So there are 5 properties are there. So starting from the number 1, here it is the transpose of a given matrix A is equal to the given matrix A. So let us discuss this property by taking an example. Let A is equal to 1, 2, 3, 4, 5, 6. It is the given matrix. So first of all we have to find out A transpose. So A transpose is equal to the transpose of the given matrix. Just we have to interchange the rows and columns. That means the rows will be placed as the columns and the columns will be placed as the rows. So here it is the first row, it will be placed as the first column. Here it is the second row, it will be placed as the second column. So here it is A transpose. Then we have to find out the transpose of the transpose of A. So it is, so first of all we have to put the A transpose value here, and A transpose is here 1, 4, 2, 5, 3, 6. Then we have to find out its transpose again. Again we have to convert the rows into columns. So 1, 4, the first row will be placed as the first column. The second row will be placed as the second column. The third row will be placed as the third column. But this is equal to A. So from equation 1 and 2, we have A transpose of A is equal to A. So transpose of A is equal to A, and here is true. Then moving to us to the property number 2. Now let us discuss about the property number 2. Let A be any matrix and K is a scalar. Then a transpose of the multiplication of the scalar K with the matrix A is equal to the multiplication of the scalar with the transpose of the given matrix A, which is defined as like this. The transpose of the multiplication of the scalar with A is equal to the multiplication of the scalar with the transpose of the given matrix. So let us consider an example here. Let A is equal to 1, 3, 5, 7 and K is equal to 4, be any scalar. Be any scalar. Then we have to show that. The transpose of the 4 multiplied with 8 is equal to the multiplication of 4 with the transpose of the matrix A. Just we have to show that. So first of all, let us find out 4 multiplied with 8. It is 4 multiplied with the matrix 1, 3, 5, 7. So it is 4, 12, it is 20, it is 28. Then we have to find out the value of the left hand side first. The transpose of 4a, that means the transpose of 4, 12, 20, 28. So it is 4, 12 in the column manner, then 20, 28 again in the column manner. So here it is the left hand side. Just we have to find out the right hand side value. But to find out the right hand side value, first of all we have to find out A transpose. So A transpose is equal to, it is 1, 3, 5, 7. We know that A transpose is equal to. Then in the right hand side part, just we have to find out the multiplication of the scalar 4 with the transpose of the given matrix A. So it is 4 multiplied with A transpose. So it is 1, 5, 3, 7. And here it is 4, 20, 12, 28. And from the left hand side and the right hand side, you can write down so here you can also write down. So 4 multiplied with, the transpose of the 4 multiplied with A is equal to the transpose of 4 multiplied with A is equal to the multiplication of 4 with the transpose of A, and here it is 2. Then moving towards to the property number 2. Then moving towards to the property number 3, let A and B be any two matrices of the same order. Then the third property tells that the transpose of the sum of the two given matrices is equal to the sum of the individual matrices. So if A and B are any two matrices of the same order, then the property number 3 tells that the transpose of the sum of the two matrices A and B is equal to the sum of transpose of A and transpose of B. And we have to prove this property by taking an example so that it will be clear to you. Let A is equal to 1, 3, 5, 7 and B is equal to 2, 4, 6, 8. We have to show that transpose of A plus B is equal to the sum of A transpose plus B transpose. So to prove this property, first of all we have to find out the transpose of the given matrices. Here A transpose will be 1, 3, 5, 7 and B transpose is equal to, it is 2, 4, 6, 8. Then we have to find out A plus B, the sum of A and B. So here it is 1, 3, 5, 7 and 2, 4, 6, 8. Then it is 1, 2, 3. Then it is 3, 4, 7, 5, 6, 11. Then it is 7, 8, 15. Then we have to go through the left hand side first. And it is the transpose of the sum of two matrices A and B. So here it is the transpose of the matrix A plus B. Now it will be 3, 7, 11, 15. So here it is the transpose of A and B. Then we have to find out the right hand side part and we have to check that if they are equal or not. So the right hand side part is the transpose of A plus transpose of B. So here it is the transpose of A is here 1, 5, 3, 7 plus the B transpose is here 2, 6, 4, 8. Just we have to add them. So it is 1, 2, 3, 5, 6, 11. Then it is 3, 4, 7, 7, 8. It is 15. And you can see that these two matrices are equal with each other. So the transpose of A plus B is equal to the transpose of A and transpose of B. So here it is the proof of the property number 3. Then we will go to the property number 4, which is as like as the property number 3, but we have to subtract the one matrix from another matrix and we have to prove the property number 4. Now let us discuss about the property number 4. If A and B are any two matrices of the same order, then the transpose of the subtraction of A and B is equal to the subtraction of A transpose and B transpose. And we have to prove this property by considering an example here. So let us consider an example here. Let A is equal to 7, 6, it is 9, 8. And B is equal to 1, 3, 4, 2. Okay. Then we have to show that the transpose of A minus B is equal to A transpose minus B transpose. So first of all, let us find out the transpose of A. It is 7, 6, 9, 8. And V transpose is equal to here V transpose is equal to 1, 3, 4, 2. Then we have to find out the subtraction of A and B. Now A minus B, it is 7, 6, 9, 8 minus 1, 3, 4, 2. It is 7 minus 1, it is 6, 6 minus 3, it is 3, 9 minus 4, it is 5, 8 minus 2, it is 6. Then we have to go through the left hand side part. It is the transpose of A minus B. That means the transpose of 6, 3, 5, 6. So it will be 6, 3, 5. Okay, now this is the transpose of A minus B. Now we have to go through the right hand side part, which is equal to A transpose minus B transpose. So by putting the value of A transpose here, 7, 9, 6, 8 minus B transpose is here, 1, 4, 3, 2. So it is 7 minus 1, 6, 9 minus 4, it is 5, 6 minus 3, it is 3, 8 minus 2, it is 6. Now we can see that both of them are equal with each other. So we can write down that transpose of A minus B is equal to A transpose minus B transpose. So here it is the completion of the property number 4. Now let us go through the last property, the fifth property of transpose of matrices. Coming to the last property, the fifth property of transpose of matrices. So here it is, if A and B are any two square matrices of the same order. If A and B are any two square matrices of the same order, then the transpose of the multiplication of A and B is equal to the transpose of B multiplied with the transpose of A. So it is very much important because just the matrices are interchanging their places whenever we are finding out the transpose of their multiplication. So the generalized form is also there. If A, B, C are the three matrices conformable for the products in the bracket A, B outside C and A multiplied with in the bracket B, C, then the transpose of the multiplication of A, B and C is very much equal to the transpose of C multiplied with the transpose of V multiplied with transpose of A. So let us discuss about the property number 5 by considering an example here. Let A is equal to 2, 1, 3, 4 and B is equal to 2, 5, 3, 4. We have to show that the transpose of the multiplication of A and B is equal to V transpose multiplied with A transpose. So first of all we have to find out A transpose and V transpose. Transpose of A is equal to 2, 1, 3, 4. Then V transpose is equal to, it will be 2, 5 in the column manner and then 3, 4 in the column manner. So here it is A transpose and V transpose. Then we have to find out the multiplication of A and V. So it will be 2, 1, 3, 4 multiplied with the matrix 2, 5, 3, 4. So here it is 2, 1 will be multiplied with 2, 3. The respective elements will be multiplied with the corresponding elements. So it is 2 into 2, 4 plus 1 into 3, 3. Then this 2, 1 with 5, 4. So it is 2, 5, 10. Then 1 into 4 it is 4. Then this 3, 4 with 2, 3. So 3 into 2 it is 6. 4 into 3 it is 12. Then this 3, 4 with 5, 4. 3, 5 this is 15. 4 into 4 this is 16. So it is 7, 14, 18 and then this is 31. So here it is the multiplication of A and V. Then we have to find out the, so this is the left hand side part. So transpose of AV. So transpose of 7, 14, 18, 31. It will be 7, 14 in the column manner, then 18, 31 in the column manner, and here it is the left hand side part for the given problem. Then we have to find out the value of the right hand side part here. So RHS, coming to RHS, V transpose multiplied with A transpose. So V transpose is here 2, 3, 5, 4 multiplied with A transpose. This is 2, 3, 1, 4. Let us find out their multiplication here. So 2, 3 with 2, 1, it is 2 multiplied with 2, it is 4, 3 multiplied with 1, it is 3. Then this 2, 3 with 3, 4. So 2 into 3 it is 6, 3 into 4 it is 12. Then 5, 4 with 2, 1, 5 multiplied with 2 it is 10, 4 multiplied with 1 it is 4. Then this 5, 4 with 3, 4, 5, 3 is 15, then 4, 4 is 16 here. So it is 7, 18, 14 and 31. And you can see that both of them are equal with each other. So hence the transpose of the multiplication of the given matrices A and V is very much equal to the multiplication of V transpose with A transpose, and here it is proved. So today in this particular video session, just we have discussed about the transpose of the matrices, and then we have gone through the 5 different properties of the transpose of matrices. In the next video session, we are going to discuss about the symmetric matrices, skew symmetric matrices, and 10 theorems based upon the symmetric and skew symmetric matrices. Till then, thank you.